Bismillahirrahmanirrahim. Assalamu alaikum students. I am Ms. Zakia, your chemistry teacher. Today it's our lecture number 4 from chapter number 5, Physical States of Matter. And the topic is laws related to gases, in which we are going to discuss about Charles' law. Laws related to gases. A sample of a gas can be characterized by 4 variables, that is pressure P, volume V, temperature T, and the number of moles of a gas N. Gas laws. What is gas law? The relationship that expresses the influence of the one variable on another with two variable constant are called gas laws. Means to study any gas law from these 4 variables, 2 are always kept constant and we will study the effect of one variable on the other. This is known as gas law. For example, in Boyle's law, PV is equal to constant. Here, temperature and the number of mole of a gas are constant. So, what is the effect of pressure on the volume of a gas? In Charles' law, V upon T is equal to constant. Here, the number of mole of a gas and pressure are kept constant. So, what will be the effect of temperature on the volume of a gas? We will study in Charles' law. In Galois's law, P upon T is equal to constant. The number of mole of a gas and volume are kept constant. While in Avogadro's law, V upon N is equal to constant. Here pressure and temperature are kept constant. Students, in your course, you have only Boyle's law and Charles' law. As in previous lecture, you have learned what is Boyle's law. So today we will discuss about Charles' law. What is Charles' law? When pressure is held constant, the volume of fixed mass of a dry gas is directly proportional to its absolute temperature. It states that pressure is constant, volume of a fixed mass. Fixed mass means the number of mole of a gas is also constant. So, temperature and volume both are having the direct relation with each other. When two measurements are in direct proportion, then any change made in one of them affects the other through direct variation. Direct relationship shows that if we increase the temperature, the volume also increases. If we decrease the temperature, volume also decreases. As we can see here, that some amount of a gas are placed in a cylinder. The temperature is 200 Kelvin and the volume is 5 liter. If we increase the temperature from 200 to 400 Kelvin, volume also increases from 5 liter to 10 liter. Pressure is constant, 1 atm. The number of mole of a gas are also constant. Why the volume increases? As the temperature increases, the average kinetic energy of gas molecules also increases. So the molecules of a gas hit the wall of the container more frequently and energetically. As a result, the volume increases. Mathematically, we can write that V is directly proportional to T. V is equal to constant into T. प्रोपोर्शनलिटी के साइन को जब हम इक्वल में चेंज करते हैं तो हम एक कांस्टेंट लगाते हैं. कांस्टेंट इस मल्टीप्लाई हो रहा है T के साथ राइट हैंड साइड पर. जब हम टेम्परेचर को लेफ्ट हैंड साइड पर लेकर जाएंगे तो वो डिवाइड होगा. सो द इक्वेशन विल बी V upon T is equal to constant. Now, if we draw a graph between volume and temperature, the graph is always in a straight line. A straight line between the temperature and volume suggests that there is a direct relationship between volume and temperature. Means as the temperature increases, the volume increases because faster molecules collide harder and push each other further apart. Derivation of formula. According to Charles' law, V is directly proportional to T. V is equal to constant into T. And V upon T is equal to constant. Let V1 and T1 be the initial volume and temperature of a fixed mass of a gas. Means before changing the temperature, it is T1 and the volume is V1. Now by heating up the gas and keeping the pressure constant, temperature rises up to T2 and the volume also increases to V2. Now if we keep the pressure constant and increase the temperature from T1 to T2. The volume will also increase from V1 to V2. Similarly, on cooling, the volume of the gas decreases. Means if we decrease the temperature, the volume also decreases, as there is direct relation between temperature and volume of a gas. Hence, we can generalize the formula and write it as V1 upon T1 is equal to V2 upon T2 is equal to constant. Unit of temperature is preferred to be in Kelvin, also known as absolute temperature. Here, students, note one thing, that in Charles' law, temperature is given in T capital. Means it shows that it is in Kelvin temperature. In any question, if you have given the temperature in degrees Celsius, then you have to change the degree Celsius into Kelvin temperature by adding 273 on degree Celsius temperature. For example, if you solve a question, here the temperature is given in degree Celsius, that is from 0 it increases to 5 degrees Celsius, then 10 degrees Celsius, 15 degrees Celsius and 20 degrees Celsius. As it shows that the temperature increases, so the volume also increases from 107.9 to 109.7, 111.7, 113.6 and 115.5. So first of all, to solve the question, we have to change the degree Celsius temperature into Kelvin temperature by adding 273 on each degree Celsius temperature. For example, 0 plus 273, it will be 273 Kelvin. 5 plus 273, 278 Kelvin. 10 plus 273, 283 Kelvin. 15 plus 273, 288, and 20 plus 273, it will be 293 Kelvin. So now we have to solve the last column, that is V upon T. That is the Kelvin temperature. Volume 107.9 is divided by 273, that is Kelvin temperature. Similarly, 109.7 is divided by 278. 111.7 is divided by 283 Kelvin. 113.6 will be divided by 288 and 115.5 will be divided by 293. And the answer will be 0.39, 0.39, 0.39. It shows that a constant value is found. The ratio V upon T is fairly constant, thus volume of gas varies directly with absolute temperature. So students, now your homework, you have to solve self-assessment exercises 5.1 and 5.2, that is related to Boyle's law and Charles' law. And thank you.